Hello, geometry students. Okay, today we are going to define 4 segments that are then used to define the 4 points of concurrency within triangles. Okay, so you ready? Okay, so here we are, the 4 segments that we need to learn about in order to talk about the 4 points of concurrency. The first one is called the perpendicular bisector. And so you can see the definition is the perpendicular line passing through the midpoint of the side. So if you look at the picture here, if you look down at where the line is intersecting the side perpendicularly, you can see that we have a marking showing that on either side of that, those two sides are congruent. That makes it the bisector. And the fact that it's hitting it at a right angle makes it perpendicular. Now, one thing to notice about the perpendicular bisector is that it does not necessarily pass through the vertex. It does when it's an equilateral triangle, but we'll talk about that later. Okay, the second segment you need to know is the angle bisector. Well, as you can guess from its name, it's the line that divides an angle into 2 equal halves. And so you can see on the picture over here, it starts at the vertex, it goes to the side opposite, and it leaves us with 2 congruent angles. It bisects that angle. All right, a median is the next term we need to know. This is the line that connects a vertex with the midpoint of the opposite side. Now, in this picture, it looks perpendicular, but it isn't always. For example, if you were to draw the median of the triangle below it, you can see that to hit this line down here in the middle, you would definitely not have a perpendicular line. And the final term that we need to know is the altitude. The altitude is the word for a line that is the perpendicular line that goes from a vertex to the side opposite. So we have 2 definitions that involve perpendicular. Let's just take a look at the difference. The perpendicular bisector versus the altitude. So here are 2 differences. First, perpendicular bisector, that word bisector, that means it has to hit at the midpoint of that opposite side. The altitude does not. Then the second thing to note is the altitude originates at the vertex. The perpendicular bisector does not have to. Okay, so that would be the difference between those 2 terms that use bisector, or that use perpendicular. All right, we're going to now take these 4 segments and talk about how they're used in points of concurrency. Points of concurrency mean places where lines meet up. So in a triangle, the circumcenter is defined as the point of concurrency for the 3 perpendicular bisectors. So note, we've got these 3 lines coming into the 3 sides of the triangle. They all hit the triangle at a right angle. They all divide the sides into equal pieces. And the place where those 3 lines meet is called the circumcenter. And I'll just give you a little preview. The circumcenter is what we use to circumscribe a circle around a triangle. That means to create the triangle that has all 3 vertices on its circle. And the circumcenter is the center of that circle. All right, the InCenter is the point of concurrency made by finding where all of the angle bisectors intersect. So you can see we've got 1, 2, 3 lines that each bisect their respective angles, and the place where they meet is the InCenter. And the InCenter is what you use when you want to create a circle that is inscribed in your triangle. The InCenter is the center of that circle. All right, the next definition is the centroid. And the centroid is the point of concurrency for the medians of a triangle. So this is, again, connecting our vertex to the midpoint of the opposite side. And so the centroid is the point of concurrency. And we'll do another video. There is a formula for how to calculate the position of the centroid based on the coordinates of the three vertices. So we'll look at that in another video. And then our final definition today, the orthocenter, is the point of concurrency for the three altitudes. And again, the altitudes are the lines that connect the vertices of a triangle to the side opposite in a perpendicular fashion. So we have our three perpendicular lines here, and the place where they intersect is called the orthocenter. So this was a definition heavy video, but this is just to help you learn and understand the terms that you'll be using going forward. All right, so study those, take a screenshot if you want and print it out, and then stay tuned for more videos. And as always, keep mathing.